let's see what we talked about. So in fact, the first paragraph just explains, reminds us what we have talked so far. So I will just read this first paragraph. So we have seen techniques for differentiating basic functions such as x to the n, sine x, and cosine x, other trig functions, some polynomials, as well as sums of functions, differences of functions, products or quotients of functions, and constant multiples of these functions. So those are the things we have learned so far, and we just seen some examples on them in the exam. And however, these techniques do not allow us to differentiate combinations or compositions of functions. Okay, so we will remember compositions of functions. Sine of x cubed, for example, is a composition of functions, two functions. So the x cubed function and the sine function, if you just apply both functions back to back, you would just first evaluate x cubed and then plug it into the sine function. Then this is a composition of two functions. Or look at the function k. There is a square root function, and inside the square root there is the 3x squared plus 1, a polynomial. Okay, so first a number is evaluated in a polynomial, and then it is put inside the square root. So two different type of functions are performed. So for such functions, which are composition of two or more functions, we use a rule which is called the chain rule. Okay, so I won't go into details on how to derive this rule. Let's call it F. And let's say the function g of x is the x cubed function. Sine of x cubed. Here, x is first plugged into the g function, the x cubed function, and then that expression is plugged into the f function. Okay, so f composition g. So this is how we write it: f composition g of x. F composition g of x means first apply the g function to x. So this is the closure function. So it first finds g of x, and then take that expression and plug it into the f function. So the g function is the x cubed function. We first find x cubed and then plug it into the f function, which is the sine function. So this tells us to find sine of x cubed. Okay, so there are two functions involved in here. And so if we just call this and give it a new name, the h function. So we defined it as sine of x cubed, okay, which is in fact a composition of two different functions, sine of x and x cubed function. And how do we find its derivative? Okay, so the chain rule will show us how to find the derivative of composition of functions. So we should acknowledge that the derivative of this function will depend on the derivative of both functions. So I will just come to the rule here. So if we have two functions f and g, like we had sine of x and x cubed, for all x in the domain of g, for which g is differentiable at x. So this is the h function. So the h function is like the sine of x cubed function, right? And we already defined it as f composition g of x, right? where f function was the sine function and g function was the x cubed function. So the derivative of this expression, so here comes our rule, this is the chain rule. It tells us that the derivative of the h function is equal to the derivative of the f function evaluated at g of x times the derivative of the g function. Okay, so remember we acknowledge the fact that the derivative of the composition will depend on each function separately. So we will find the derivative of both sine of x and the x cube function. And since this is like the x cube is evaluated, I mean the sine function is evaluated at the x cube value, x cube expression, we will also need to plug in that expression x cube inside the sine function. So let's see some examples. And I mean, reading it as f and g may be difficult, so I'm not putting this down. You can just copy it from the textbook in your notes. So this is the chain rule, and we will see some examples. Okay, so here it just gives you the problem solving strategy to differentiate a composition of functions. First identify f and g and find the derivative of each and just evaluate the derivative of f at the g function. So plug in the value of g and multiply the two derivatives. Okay, but I mean, again, just trying to memorize these with f's and g's are difficult. So we will instead see some examples. Maybe we will just go over this problem and you can, sorry. Okay, so let's do this problem and you can just go over the solved problem yourself. Okay, so h of x is a polynomial raised to some exponent. Okay, and we want to find the derivative of the h function. Okay, so remember this is the same as saying, this notation tells us to differentiate h or find the derivative of the h function. Okay, so there are two functions here. One is the, let me just say, 2x cubed plus 2x minus 1. So this whole polynomial is raised to the fourth power. Okay, so if, let me just do it this way, if you call this expression as u, then we also have u to the fourth, right? So here this expression is raised to the fourth power. So you can identify the two functions if you just give this one a name. So let's say now we can just go back to the same notation. If the inside function, so the function that is inside, which means first we are just applying another function to this, which is we are just taking it to the fourth power. So the function that we are taking to the fourth power is g of x, and the outside function, which is applied last, okay, so the outer function, which is applied last, is u to the fourth, we called it. So in fact, just call it x to the fourth. Okay, so let me say it this way. You don't have to call these f or g. So you would just need to identify which was done first and which is like the inside function, the outside function. What do you mean by outside or inside? So remember, composition means it tells us like which order are the functions are being applied. So first, x is plugged into this polynomial, into the g function. So this is the inner function, or the function that is applied first. And then what you find is plugged into the f function. So f takes everything to the fourth power. So this is the outside function, the next function. Now let's look at the derivative. So we will start by taking the derivative of the outside function, or the function that was done last. And what is that? This is what we see as the main function. Okay, so I would just say these. The main function we see is the outer function, or the function which is performed last. Okay, in this case, it is the x to the fourth function. Okay, so what we called f. So first, x is plugged into a polynomial, and then the whole thing is raised to the fourth power. So this is called, like, the x to the fourth is the main operation we see, which is done last. So we start by taking the derivative of this main function. Okay, so if you just we call this u. If you just think about it, you just want to find the derivative of u to the fourth. And what is that? So if you have anything to the fourth power, so if you have x to the fourth power, what is the derivative of x to the fourth? Derivative is 4x cubed. Okay, so just 4 raised, taken down and decreased by 1. So we take the derivative of this outer function. So the parenthesis raised to the fourth power. When you take the derivative, we will take 4 to the front and decrease it by 1. Okay, so this is the derivative of the outer function, and the inner function is evaluated at this, this function is evaluated at the inner function, so just keep it inside, just plug it in. Okay, so this is the derivative of the outer function, the inner function, times, we will just multiply this with the derivative of the g function. Okay, so what is the derivative of the g function? We call g as the inner function, which is done first, okay, which is evaluated first. So we just find its derivative, which is 6x squared plus 2, right? The derivative of this, which is 6x squared plus 2. So we multiply it by 6x squared plus 2. Okay, so let me go back. Now, what did we do? We wanted to find the derivative of this composition. Okay, so there are two functions involved. One is the polynomial, the inner function, and one is the x to the fourth function, the outer function, which is done last. So find the derivative of the outer function, right? So 4x cubed, but evaluate it at that value of the inner function. So plug in the inner function itself and multiply this with the derivative of the inner function. So this part is simply the derivative of the inside function, and this part is the derivative of the outer function evaluated at g of x. Okay, so this was what the chain rule told us, and this is how you do it on a problem. Okay, so let's practice that. And in fact, this is the only thing we will do today. So just use different functions to practice the chain rule. Okay, so let's first differentiate f of x, which is, okay, so let me double check, sine cube of x. What is sine cube of x? This is just find sine of x and cube it, Okay, so because there's cube here, okay, so there are two functions. One is the sine function, and once you, after you find the sine function, you cube it. So one function is the x cube function, one function is the sine x function, right? Which is the inner function, which is done first, which is performed first, and the inner function, sine of x. So this is the first function, like this is inside, which we normally call g, and this is the outside main function, which is done next, right? This is the main function. So, okay, let's find the derivative of, we call this f. Maybe I'll just change it so that we have similar notation. So h of x, let's find the derivative of h of x. Now, we first find the derivative of the outer function, right? So the outer function is this x cube function. What is its square? That's right, 3x squared. But remember, we evaluate this at the inside function, so we just plug in sine of x, okay, times the derivative of the inner function, which is cosine x, okay. So this is the derivative of the inside function, and 3 times this expression squared is the derivative of the outside function, and we evaluate it at the inner function. So we can just write this as 3 times sine squared times cosine of x. Here we first find x cubed and then put it inside the sine function. Okay, so this is the inner function that is done first, x cubed, and the outer, the main function is sine of x. So this is the outside, the outer function, which is done last. This is the inside, inner function. Okay, so we, like the outside is the main function, we take its derivative. What is the derivative of sine? That is cosine of, we plug in the inside function, right? So instead of finding, like we have sine of x cubed, and when we want to find its derivative, we will just find cosine and evaluate that x cubed, yes, times the derivative of the inside function, which is 3x squared, the derivative of 3x cubed, which is 3x squared. That's it. But I would just write this in the front, 3x squared, and let me tell you why. And you use parentheses, it is clear that cosine is evaluated at x cubed, and the whole function is multiplied by 3x squared. But I just changed the order of this product just to get rid of this parentheses. So if you just put this in the front, you don't need to put parentheses around x cubed, because it's going to be obvious that this is the cosine of x cubed. Okay, so when you see this, this means you just take the cosine evaluated at x cubed, and you don't need to put parentheses. But if you see cosine cube of x, that means you find cosine of x and you cube the results. Okay, but here the outside function is the f function, the inside function is the g function. So we found the derivative of the f function and plugged in the g function inside and multiplied it by the derivative of the g function. Okay, so this is the derivative of the composition. Okay, let's see some other examples. Let's find the equation of a line that is tangent to the graph of h of x, which is this function at x equals 2. How do you find the equation of a line that is tangent to h of x at x equals 2? So we have a function y equals h of x, and we are given a point. So in this case, we are given that x equals 2, not given the y value. And we would like to find the equation of this line that is tangent at this point. So we need to know the slope of this line. And how can we find the slope of this line? By finding the derivative of that function and evaluate it at that x value. Okay, so if we just find derivative of f and plug in 2, the x coordinates, we will find the slope of that tangent line. Okay, so let me just do it here. So the slope will be the derivative of h at 2. So what we need to do is we should find the derivative of the h function. Okay, so let's find that, and then we can plug in 2. Now let's look at this function. You can rewrite this function because you have something in the denominator. Can we say h function is 3x minus 5 raised to the power, we are supposed to put negative 2 here. Negative exponents would move things from to the denominator. So to move it back, you can just make the exponent negative. Okay, so if this is the h function, so h function is 3x minus 5 to the power negative 2. What is the inside function? So we call the inside function as g of x. That's correct. 3x minus 5 is what is done first. And we called the outside function as the f function, which is what does the outside function does, which takes everything to the negative second power. Let's find the derivative. We will first find the derivative of the outside function. So this negative 2, so something raised to the negative 2 is the outside function. So move it to the front and decrease the exponent by 1. So 3x minus 5. And then we multiply by the derivative of the inside function, of the g function, which is the derivative of 3x minus 5, which is simply 3. Okay, so let's write this. Negative 2, 3x minus 5. In fact, this is negative 2 times negative 2 times 3, which is negative 6 times 3x minus 5 to the negative 3. So this is the derivative of the h function. Now, we want to find, we need to evaluate this at 2, because we would like to find the slope at 2, the slope of the tangent line at 2. So plug in 2. Okay, so 3 times 2 is 6, minus 5 is 1. 1 to the any power will be 1. So this is simply negative 6. Okay, so we found the slope as negative 6. Now let's find the y coordinates of this point. It is h of 2. So because the point we are evaluating at x equals 2, so h of 2 will give us the y coordinate of this point. 1 over 3 times 2 minus 5 squared. Again, we will find 1 here. Sorry, 6 minus 5 is 1. 1 squared is 1. So this point is in fact the point 2, 1. So the slope is -6 and the point is 2, 1. You can use y equals mx plus b formula, or I will go ahead and use y minus y0 equals m times x minus x0, which is 2. So y minus 1 equals -6x plus 18, and y equals -6x plus 19. So this is, let me delete, this is supposed to be -6 times 2, which is 12, and add 1, so that will be 13 then, right? -6x plus 13. Let me see, in fact, yes, we also have it in the book, same. Okay, so here it is also given in the textbook. So it is called the Leibniz notation. Instead of using f and g, you can also represent like with u, but as long as you understand the idea, whichever you understand better. I think because we spent more time on f and g, so we can stick on that. But sometimes, let's look at this question. And we would like to find the derivative of this function. Y prime, or dy over dx. What you just need to identify is what is done last. So this whole thing is raised to the 5th power. So when you take the derivative, first take it to the front and decrease the power by 1. Okay, so this is the outer function, and we will just plug in what is inside, times the derivative of the inner function. Well, the derivative is not straightforward, so I will just put it here. So the derivative of y equals 5 times this expression to the 4th power times the derivative of the inside. Okay, the derivative of the outside function times the derivative of inside. Okay, so let's do that. And now let's look at this parenthesis. Let's take its derivative. So the derivative of x is 1 times the denominator minus derivative of 3x plus 2, which is 3, times the numerator, divided by the square of the denominator. Let's simplify. So 3x plus 2 minus 3x, in fact, is simply 2, right? This 3x minus 3x will cancel out. 2 over this thing squared, right? And I think we can write this better. So multiply 5 and 2, which is 10. And we have x to the 4th divided by, we have 3x plus 2 in the denominator. Here it is raised to the 4th power. Here it is raised to the 2nd power. So there will be total of 6 powers, right? So here, the first expression, you will get this. And in the second expression, you have this. So when you multiply, you have 6 factors of 3x plus 2. So if you want to call it f and g, let's identify them too. So remember, f represents the outside function. This is x to the 5th. So the whole thing, the parenthesis raised to the 5th power. And g of x will be the inside function. And here we had the f function's derivative evaluated at g. And here we have, this is the derivative of the g function. Okay, maybe we can look at this problem. This looks nice. Okay, here there are in fact a composition of three functions. Yes, so this is an example. Sine to the power 6x cubed. Let me copy the question. Okay, so this is an interesting one where we have in fact three functions. So a function inside another function inside another function. Now let's put this 6, let's rewrite this function so that we can understand it better. So here we have the sine of x cubed raised to the 6th power. Okay, so if you just rewrite it, you will be, it's going to be easier to see which is done first, which is done last. So here, this function first takes x and evaluates x cubed. The next function evaluates sine of x, given any x. The last thing done is the x to the 6th function. So we will start by taking the derivative of x to the 6th, x to the 5, and we will just find the derivative of sine, which is cosine x. We will need to use the derivative of this, which is 3x squared. So start from the outermost function. Let me just put it here. The derivative of y. So this 6 will go to the front. We will just keep what is inside. So 6 times sine of x to the 5th power. Okay, so the outermost function, take its derivative and evaluate it at the inside function. Okay, so this is the derivative of the outermost function. Now we will multiply it by the derivative of the inside function, which is sine of x cubed. The derivative of sine of x cubed. Well, in fact, we are applying the chain rule twice. So this is now here to find this derivative. We again will apply the chain rule. So let's do that. So the derivative of sine is the cosine function. We had already noted this down, but it's going to be evaluated at the x cubed function. Okay, so this is the cosine function, which is the derivative of sine, but just evaluate it whatever it is given in the question, which is the x cubed function. And the last piece will be the derivative of the x cubed function, which is 3x squared. So let's now go back. So there are three pieces here. This is the derivative of the outmost function, evaluated at, so whatever given in the original question. Okay, sine of x cubed. Then take the derivative of sine of x cubed. So this is the derivative of sine of x cubed, right? Which brings in the derivative of 3x squared. So the 3, this is the innermost function. This is the outermost function. And this is like the in between. So we just go in the order from outside to inside. Just keep multiplying the derivatives. Always plug in the innermost function to the next function, right? And then take those and plug into the outermost function. This is what we did here. So here, the x to the 6th function, the derivative is evaluated at sine x cubed. So the middle function, its derivative is evaluated at x cubed. And the inside, like innermost function, is simply evaluated at x. Let me just copy this one. So the important thing here, once we know, like learned a few rules, to see which rule we should apply first. So here, this will be a combination of several rules. Well, we have something raised to the fifth power times something raised to the seventh power. So there are two things multiplied. So what rule do you think we should start with? F and G. So the product rule is the first thing we should use. Okay, so the derivative of H will be the derivative of F. Let me just put it this way. Derivative of F times G plus derivative of G times F. Now, come back to the F function. So F is 2x plus 1 to the fifth power. So we will need to apply the chain rule because there is the 2x plus 1 function and there is x to the fifth function. Okay, so there are two things composed. 2x plus 1 raised to the fifth power. Okay, so when we find the derivative of f, the outer function is the parentheses raised to the fifth power. So we should take it down. 5, 2x plus 1 raised to the fourth power. So this is the derivative of the outside function times the derivative of inside, which is the derivative of 2x plus 1, which is 2. The whole thing is the derivative of the f function. Okay, now the derivative, so the g function itself, which is 3x minus 2 to the 7th. So this is just the g function, plus, now let's find the derivative of the g function. 7 will go down times 3x minus 2 to the 6th. So 7 times 3x minus 2 to the 6 is the derivative of the outside function, and 3x minus 2 is the inside function. So its derivative is 3. Okay, so this whole thing is the derivative of g. Now we have the last piece, which is just the f function itself, 2x plus 1 to the fifth power. Okay, so just this is the whole thing. The rest we will see if we can simplify further. 5 times 2 is 10. Okay, so just combine this and this. 10 times 2x plus 1 to the fourth power times 3x minus 2 to the seventh power, plus 7 times 3, which is 21, 3x minus 2 to the sixth times 2x plus 1 to the fifth. Combine 2x plus 1, you can just factor that out. 2x plus 1 is a common factor, so this is to the fourth. And if you combine 3x minus 2 to the fifth power, so there are 7 factors of 3x minus 2 and 6 factors of 3x minus 2. So we can factor out that 6 factor. So this is the smallest number that is common. Here we have 4 factors of 2x plus 1, and here we have 5 factors of 2x plus 1. So the smaller number is 4, so that is common. We can take it out. And just write here what is remaining inside. So 10, this is all taken out, factored out, and only 3x minus 2. So 6 factors are taken out, so there's just 1 factor remaining, plus 21 times. So all these 6 factors are taken out, and only 4 factors are taken out, so just 1 factor is remaining. So this is how you would simplify. So the rest will be just multiply out and simplify the inside expression. Okay, and then you will have 1, 2, and 3 factors. Okay, you can check the textbook.